Okay, so welcome back. We are going over some more of this chapter, which we have been calling the redemption chapter. So, again, nothing new in this chapter. I don't know if you've noticed, but nothing new. We are being more mature in our math, right? In that I know I did, sorry. In that we are now not only doing the steps, but we also have to describe why we can do that. So, we were talking about the properties, right? I lost something. Hold on. Okay. So it says, for this one, it says which one doesn't belong. I'm going to kind of skip over this one really quick. Just whenever I'm asking you to do which one doesn't belong, there's a lot of skill in this. In fact, if you remember, I don't know, are you part of the era that watched Sesame Street? Did you guys watch Sesame Street? Yes. Okay. There was actually a segment in Sesame Street called which one of these don't look like the other? There was like a little song even. It was like, which one of these don't look like the other? Don't know how to sing it, so sorry. So it's actually a really huge skill, right? It's a skill for you to be able to look at these and compare and decide which ones of these don't belong. The reality is all of them don't belong. The real goodness, I don't know what to call it right there. The goodness that comes out of this exercise is you being able to explain your reasoning. And we talked about the importance of you being able to explain and justify how you think about something. So maybe someone says, "Hey, Miss Johnson, I think that the C doesn't belong because like this is a number line, this is a number line, and this like you can graph this on a number line, Miss Johnson, right? But this one you cannot, right? So and so that could be one reason because it looks physically different. I'd probably argue this one as well because like, hey, look, this is the only one that's an expression. All of these are representations that are like pictorial in nature. And then someone might say this one doesn't belong because I don't know if you guys know this, but this all represents like some version of x plus 4, right? This is -5, and then you add 4 to it. This is a number, and we add 4 to it. This is x plus 4, but this one is like 3 sets of things. So there's each of these is a really powerful way for you to be able to explain something. All right. So today you'll be able to reason about inequalities. An inequality is not an equation. Equality means an equation. Inequality means not equal. An inequality is when we're using these symbols like this guy down here. This is greater than. There's a couple other symbols that we'll talk about as well. Justify properties of inequalities. Again, we're going to be talking about properties. Use inequality notation. So we're going to be talking about different notation. You guys have learned some notation from earlier this year. And what are properties of inequalities? Are they different from properties of equations? So a property in terms of mathematics and in terms of other things too they will hold true for all inequalities. Okay. So I've done this before with my students. I say, hey, what are some human properties? Okay, we're going to do this fast, so put your answer in the chat. I don't have a lot of time. So, what are some human properties? What are some human properties? So, again, a property is something that will hold true for all humans. Hint, hint, right? All humans. So, someone put in the chat eyes, and they put it privately to me, which is kind of fun. So, are you saying that if a person loses their eyes, and I actually know someone who has lost their eyes, are they no longer human? And the answer is no, they're still human. They just don't have eyes, right? Okay, so someone else says we all need food. Yes, that's a really good. Yes, a heart. Yes to the food. Because yes, we all need to eat food in some way, shape, and form. Now, some of our food doesn't look like food. Like if you take a baby human, I would never eat their food. I would never, ever eat their food. But it is food nonetheless, right? Someone else said water. Exactly. Someone else said is a brain. Keep going. So those are all properties. So you did better than some of my other classes. My other classes will say things like arms and legs and fingers and toes and ears and mouths and stuff like that. And I'm like, not so much, right? So a human, it does not let's see, how do I put this? If someone does not have arms or legs, it does not count them out as being human anymore, right? Okay, let's move on. So a property is something that holds true for all inequalities. So given a mathematical statement and two expressions, decide which of the two expressions is greater. If the expressions are equal, or if the relation can't be determined from the statement, write an equation or inequality that show your answer and explain why your answer is correct. Watch out, this gets tricky. So I'm going to do this very, very first one with you, and then I'm going to have you think about some of these other ones, okay? So this is a really good practice. So before you've already dealt with equations and inequalities, you'll kind of remember some of them. But I'm really hoping that you guys see the bigger kind of thinking that I want and the logic that I want you guys to grab. Okay. It says statement x equals 8. X equals 8. So here's your question. Which is greater, x plus 5 or 3x plus 2? So ignore this statement. Just kind of think about it right now really quick. X equals 8. Which is greater, x plus 5 or 3x plus 2? Okay. So some of you are like, oh, I get this. I understand how to do this. So they say, oh, 3x plus 2 is greater because 3x plus 2 is greater than x plus 5, because if x is 8, then you plug it in, right? 8 plus 5 is 13. 3 times 8 is 24 plus 2 is 26. So therefore, this guy is bigger than this guy. Everybody okay with that? So what did they use here? They just plugged it in. Okay. They just plugged it in. Some of these, you're not going to be able to do that because they have really big topics. So we're going to start with this one. Statement n is an integer. In case you forgot what an integer is, it's all the numbers that you would count with as a little child. 1, 2, 3, 4, 5, 6, 7, all the way. And their opposites. So -1, -2, -3, -4, -5. So an integer is whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 100, and their opposite, -1, -2, -3. Which one's greater, n or -n? I'll say it a different way. Which is greater, n or the opposite of n? N?
The non-opposite of n?
The opposite of n. What do you think? Let's vote. Okay.
I think it's n, positive n.
Okay. So I see why you guys would say that. So n is an integer. Pick a number.
2.
So is 2 an integer? Everyone's like, yes. Which is greater, 2 or -2?
2.
Yes. So n is greater in this case. Yes? Everyone's good? But wait, there's more. This all depended on what integer he picked, correct? Can you pick a different integer where n wouldn't be bigger? Can you pick a different integer where n wouldn't be greater than -n? So in this case, 2, 1, right? So someone said -7. Check that one on your own. So n is -7, right? Who's bigger? -7 or wait, what do I?
N in this case.
Oh, why?
Because a negative and a negative cancel. They make up for positive.
Very good. Negative, or the opposite of -7 is +7. That's why I was saying opposite. So the opposite of -7 is +7, right? And so because it's +7, in this case, dun, 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 7, 1 and -n1. What? And then someone else came up with a different case. Their case was 0. If you came up with the case of 0, 0 or negative 0. Negative 0 is still just 0. Neither of them when they're tied. Is everybody okay with this? So which one is it?
Johnson,
Yeah.
in this case, if both n's were to equal 0, would this mean n is equal to negative n?
Yeah. Exactly.
Weird.
Right. So in this case, so your answer here, which one is greater, is your answer is it depends. Right? It depends. It depends and it depends. Graphically, I can show you this. I would graph the line x and I would graph the line negative x. And over here on the right side, n is bigger, which is where you guys all think. By the way, you fell into the trap perfectly, right? You fell into the trap perfectly because you tend to think of the numbers that you're the most comfortable with, right? So I'm going to use the graph. I know I'm graphing non-integers, but I'm just going to show you. So I'm asking you, when I'm asking you which one's greater, I'm asking you which one's higher. And you should say it depends. The red is higher over here versus over here, it's higher over here, right? So when it's less than 0, it's over here. It's negative. When it's greater than 0, then n wins. And when they're equal to 0, then nobody wins. We're tied. So your job as a mathematician is to really think of all of these cases, right? Think of all of these cases. Okay, you're going to try this one, and then I'm going to pause, and I'm going to have you guys try it. Statement, x is greater than y. So a number is bigger than another number. Which is greater, x plus a or y plus a? Which one is bigger, x plus a or y plus a? So I'm going to give you a couple seconds to figure this out while I pause the video. All right, so what do you guys think about this one? Who wins, x plus a or y plus a? Come on, let's vote. Vote in the chat. Let's go. I only have 3 people voting. I need more. Nice. Okay, I got a bunch of people voting now. Nice. Okay, so what do you guys, so a lot of people said x plus a. I have a couple of people who said y plus a. Anyone want to explain? Go ahead. Does anybody want to explain?
I put it depends because hypothetically we could plug in any number to equal to x or y. So like my examples were for x, I took x equals 18 and y equals 11. And that would be 11 plus a and 18 plus a. And for that, I tipped it to 18. So, and in another hypothetical case, I took y equals 9 and x equals 7, and that would be y plus a and x plus a, obviously, and that tipped it towards the y scale because in that case y was bigger. There are obviously like terms you can use for negative numbers and stuff like that, but in that case it's like it depends on what each variable equals to.
Did anybody hear something that she said that might not have been correct? I heard it. You got to help out your classmate because she said something and I was like, yikes, that's where she went wrong. Did anybody hear it? So it's totally safe in here. If you make a mistake and you hear a mistake, your job is to find a way to lovingly tell this person you said something wrong. Did anybody hear it? It's okay. Hey, is it okay if they say what your mistake was? Yes. Okay, please, she said. All right. She said if y was 9 and x was 7. Will that work? Here, will this work?
No.
Very good. How come?
Because the x is always going to be bigger than the y.
Very good. So we had to start off with some constraints. So a constraint is what you have to do or what you have to stick to. So this constraint here was your x had to be bigger than your y. So that's why you use the word tipped, right? It tipped it over to the y side. So your argument for the 18 and 11 works perfectly, but actually it continues all the way through. So I don't care what a you use, it actually will always be true that x plus a, oops, I crossed it out. Try that again. X plus a always wins. Always wins. Always. So the cases that you kind of want to try are zeros and negatives and fractions and decimals. So I'm going to take off this 18 plus 11 and I'm going to use it. I'm going to take 18 is greater than 11 and I'm going to, in my head, subtract off or add certain a's to it to see if it's still true. So obviously, if I add a positive number to it, it's still going to be true. I'm going to add 10 to it. So is it true that 28 is greater than 21? Everyone says? Yeah, that holds true. Okay, so then let me try a negative number. Let me add a negative number to it. So 18, let me add negative 10 to it. So if I add negative 10 to it, I would get, let's see, I would get 8 is greater than 1. Is that true? Is 8 greater than 1? Everyone says yes. So I've tried positive numbers. I've tried negative numbers. The other numbers I kind of want to try that are always going to pull out my special cases is the one that you guys found up here, which is 0. So, but if I add 0 to both sides, you see how it's still 18 is greater than 11? Still going to work. So if I tried like decimals, it would always work. Now, if you've been paying attention to how I've been teaching how to graph, oh, wait, have I taught this class how to graph? Nope. I'll be quiet then. But this plus a, what it actually does to the number is that they both shift each other over, right? So for me, this example reminds me of my 2 children. So my daughter, who's older, she's 15 now, and my son, who's younger, he's 12 now. But back when they were younger, when he was, say, I don't know, 4, he was 4. Let's pretend he was 4. And she was 7. You want to know what he said when he was 4? What do you think he said when he was 4? That has to do with this right here. Huh? No. At 4 years old, they're not talking like that. No, he did not say I'm better than you. He said in 3... Go ahead, Johnny.
Because kids have this thing, which I had this thing with my brother, who was like, oh, I'm going to be as old as you. And I'm like, but when you're as old as me, I'll still be older than you.
That's exactly this case. Okay. That's exactly this case right here. So when my son was 4 years old, I don't know, maybe he was 3 years old. I'm not sure. But he said in 3 years, what did he say? In 4 years, I'm going to be older than you. And it's kind of true, but it's kind of not. In 4 years, he's going to be older than she is right now, but not older than she will be in 4 years. Does that make sense? So no matter what, won't you always be older than the person that you're older than in some number of years? Or go backwards as well? So the answer is yes. So the answer here is going to be x plus a. Okay. Look at statement 3, and I'm going to let you guys go. Look at statement 3. X is greater than y, so same guy, same guy. But now we're subtracting. Everyone say ooh. 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 What do you think? X minus a or y minus a? X minus a or y minus a? Just guess. Based on our conversation that we just had. Vote. Yeah, very good. It's still the same. It's going to be x minus a. Because if I'm older than you, which I am, and we go back some number of years, will I still be older than you then? And the answer is yes. Okay, let's continue. 5 is greater than 4. Which is greater, 5x or 4x? Okay, be careful. You have to be careful. Hint, hint. Be careful. Be careful. Think of all your different cases, right? Think of your different cases. Okay, so this is where I'm going to pause this. I'm going to have this conversation with you guys next time.